Welcome everybody. This is the third sprint for the Evernym team responsible for contributing to Indy and Sovereign. It is American Valentine's Day, February 14th of 2019, and we're going to post this video onto YouTube as is our custom. So feel free to check out the previous videos if you're confused about the state of the project. And of course, you can always reach out to us at chat.hyperledger.org to have conversations about our work on Indy. So we had a number of releases we're going to talk about today. A bug fix release on Service Pack on the SDK and a new release on Indy Node. And we also implemented a major feature with the Freshness change. We're going to talk about how we fixed a bug on performance degradation. And we've started our agent-agent compatibility work by documenting the Credential Exchange format that our product uses, the Evernym's products use, and getting feedback from the open source community on how to improve that. We did a number of other things this sprint as well. Long-term planning, some CI/CD work on mobile environments on the SDK side, some other bug fixes. On the Node side, we also did some additional work that's going to pay off in the future. We started building an audit ledger, and you're going to start seeing that come into master, where it will allow synchronization between all the ledgers to make sure there's reliable catch-up, especially when plugins are involved, and to make sure that people can track permissions when they're on the config ledger, and reconcile those with the domain ledger to make sure, so you can audit the permissions are match what was actually done to the domain ledger at the right point in time. And then there was a lot of bug fixes, which we're really happy with. We feel much more comfortable with the performance and reliability of the product at this point than we ever have in the past. So that's exciting. You can dig into Jira if you want to know more details about the other work that went into this, but we only have time for a couple key items. So I'll stop sharing my screen and let Vladimir take over and review the releases.
Can you hear me?
Yes, you sound good.
Let me share my screen. Can you see it?
Yes.
Okay, I want to provide a short summary of the latest releases of Indy Node and Indy SDK. So new stable Indy Node release 1.6.83 includes our Freshness feature, network monitor role for validator info also was added, and also validator info improvements were implemented due to the latest two sprints about right consensus presence and last update time. Also, there are stability fixes that relates to pull upgrade roles and permissions, and our view change and catch up. The new hotfix stable libindy release 1.8.1 includes mobile libnull pay fixes. Also, Freshness feature is disabled by default for better compatibility with sovereign test and live networks, and also it contains Freshness fixes about timestamps. So that's for me about Freshness feature. I think Sergey will tell more detailed.
Excellent, thank you. And to be clear, using an SDK that looks for freshness with a release of Indy that doesn't provide freshness can provide a performance slowdown. Since most people using the Indy SDK today is using the Sovereign Network, we'll keep that disabled until the Sovereign Network starts reporting freshness. That's expected to happen this month, so expect a future release to enable that by default. Very good. So next is Sergey, who's going to take us through some more details on how freshness impacts view change.
Hello, do you hear me?
Yep.
Great. Well, actually, freshness doesn't directly impact the view change, but there is one more feature that we implemented, which does improve stability of view changes a lot. I'll share my screen now to show some short presentation. Well, we implemented a fix that starts a view change when state doesn't get updated long enough. Well, and obviously this fix required freshness feature implemented, which we also have now, as Vladimir said. Well, why we need this fix is first because it helps detect problems with primary node even when there is no actual load, and another good thing is that it helps solve some problems when some nodes which doesn't reach quorum are stuck in a view change. And as for how it's done is as follows. But first of all, as I already mentioned, it's based on previously implemented periodic state sign-in, which is also called freshness feature, even if there is no load. When there are no incoming transactions, primary node should periodically send empty 3PC batches in order to update signatures of states. So if state is not updated long enough, then there is a clear indication that pool has some problems with ordering, so it's out of consensus and something should be done with it. And we can use this indication to vote for view change. Well, and some cases. The first case is when the primary node is slow, but there is no load. Before this fix, as long as there are no incoming transactions, pool is not aware of problems, and when transactions appear, then nodes wait until they are sure that master primary is really slower than backups, and this can take actually indefinite amount of time. Then finally view change starts, and it can be also very long. And during all these things, client will see a non-functional pool. And after fix implemented, even if there are no incoming write transactions, if states is not updated, then nodes will vote for view change will happen, and there is much less chance that client will ever see a non-functional pool. So this is a quite big improvement for the cases when the load is when the write load is very low. And as for another case is that actually currently there are situations when less than n minus f nodes can start view change, and if they do start, then they cannot finish it. And by detecting problems with ordering transactions, we can help remaining nodes to join this view change and finish it. Actually, we have some tests implemented for this. I'll show you one of the tests that actually tests this scenario. I'll start it before explaining because it will take some time. So there is a flag is state fresh enough. I'll just patch it so it returns true. So we basically know this feature, and I'll start test. At the same time, I'll give some explanations. So assume that we have a pool of 4 nodes, and alpha is primary. Then network opens and beta and gamma broadcast instance change messages. Then beta and gamma has votes, and actually delta also has votes. then primary restores connection to beta and gamma, and delta gets restarted for some reason, and it forgets about words. And then alpha loses connection to delta, and delta also broadcasts instance change. And now we're in a situation when beta and gamma has enough words to start a view change, and delta doesn't have. So we come to a position when beta and gamma are in view change, but they don't have quorum to finish it, and delta and alpha don't have any reason to start a view change. And this should be actually showed by the test. It's still running.
And that's the exact situation the Sovereign Network ended up in early December.
Yes, it's exactly the situation, and you see the test failed. Now I'll remove this malicious patch and run the test again. Well, with the fix, beta and gamma will see that state is not updated and will vote again for same for view change for same view number. Alpha will also send an instance change, and delta will receive votes from alpha, beta, and gamma. And all in all, they all receive enough votes to start a view change. So beta and gamma continue view change, alpha and delta join a view change. And now they have a quorum, and they all successfully finish a view change and then continue ordering. And well, we'll need a bit of more time, probably 10 seconds or something like this. Well, and we see the test is passed. So the fix is implemented, it's tested, it's covered by actually a lot of integration tests. That's all from me.
And that's great. I was really nervous when we saw the problem in December that it was going to be that class of view change problems we've already recognized are going to require the Ledger 2.0 re-architecture. I'm really glad we were able to address this with the current architecture. But I do recognize that it doesn't remove the need for the re-architecture that the team's identified. So we'll continue to work towards that. So thank you. That was a really useful explanation, Sergey.
Thank you.
Next is Renata. Talk about fixing the problem with backup degradation, backup performance degradation.
Hello, let me show my screen. 1 second, please. In work on the task 1933, we found an interesting problem, and now I will tell you about it. Firstly, let's talk how the performance degraded replica is removed. We made overview for this mechanism in the demo 1821 on October 25 last year. So disabling replicas is necessary because if there is an instance that cannot order or order too slowly, the queue of client requests will not be cleared and the used memory will grow. This leads to the out-of-memory error and a node restarting. Earlier, we used the same mechanism for detecting the performance degradation of backup instances as for the master instance. That is, compared the performance of each instance with the average performance of all instances. The average performance is calculated via fallaway. The problem is that if the performance of several instances is lower than others, then the average performance for all instances will be very low, and its difference with degraded instances will not be enough to remove them. The solution to this problem is very simple. We change the function to calculating the average performance for backup instances for the median low strategy to the median medium strategy. Testing has shown that the PIX solves the problem. The integration and unit tests were writing and successful, and load testing was finished successfully too. I think this is so about results. I think that is a good experience with an average calculation. It's great that we fixed such a big problem with just a small fix. That's all. Any questions?
I think this engineering is so interesting that you would expect that the medium-low strategy would be a close enough heuristic, but to move to medium-medium makes such a big difference is rather shocking. That's very interesting. So thank you for that explanation. That was really good.
Thank you.
And Nikita, we'll talk about the SDK hype for Credential Exchange.
Yes, so we started our work on formalizing the Credential Exchange and figured out that we actually need two message families. There will be a lot of terms that are special for HIPEs, so Hyperledger Indy project enhancements. To know more about them, I suggest you to go to this repo and to find out inside it what all of that means. So Credential Exchange is a process where we issue the credentials and verify that we comply to some attributes and reveal some attributes to the verifier. So there are three persons that are in this process: verify, issue, and prover. We decided to make two credential families. One is for credential issuance, where we have issuer and prover. It's the process where credential is created and stored in the prover's wallet. So we have 5 messages in it: credential offer, credential request, credential ACK, and credential reject. This is the diagram of this process. It might look quite complicated, but if we introduce negotiation in this process, it will look so. So credential offer is sent by issuer, and nothing actually changes here from the old implementation of Credential Exchange. Then credential request is sent by prover to receive the credential, and credential is actual issuance of the credential. Yeah. And two new messages. Credential reject is a message that can be sent by either side of this, but every side of this communication that will just halt the process of credential issuance. It can happen in two situations: when issuer can't issue this credential, so it can either verify that the data is true, or when when prover don't want to have this credential for some reason. And I have a misspell here. And credential ACK is sent by prover, which verifies that he have this credential and he received it from this verifier. And another family that we want to introduce in this hype is credential presentation. It's it has 4 messages: presentation request, presentation ACK, and presentation reject. So presentation request and presentation are actually were previously named proof, but they were named to presentation to be more compliant with W3C namings. And ACK and reject are the same as in issuance. Same as in issuance, to end their communication and to send the message that everything was made correctly. So presentation request, here's her choreography diagram: presentation request, presentation, And I have the same mistake here. So what's new for the messages? What differs from the older format that we have implemented in VX? So at first we used threading. This is really important because with threading we are marking on which message we are responding to. There is a set of rules how to mark the message. So it's about a thread ID and parent thread ID. And as I think it will enable the negotiation of the proof. So we will introduce attachments. We will introduce attachments. For example, we can send a preview for credential, but in credential offer for prover to see what is actually going to be issued to him. And here, prover can decide if he agrees with this credential or not. If he agrees, he just sent a credential request with this credential he received from offer, and it will be issued right away. Or he can send a credential request with another credential that he thinks to be correct. For example, if there was a typo in your name or surname or other information. And then here comes the negotiation. And threading really helps us with it. Then that's why choreography diagrams are so complex. So that's it for that HIPE. If you want to know more about it, you can find it in the HIPE repo. It's still in PRs and still in discussion. We really appreciate any feedback you can give to us, and we will review it and maybe put some questions into the HIPE or make some changes straight away.
Very good. Thank you very much, Nikita. That was really useful. I'm excited to share that video with people who keep asking me about the Credential Exchange process and how it works. So thank you. So to close out our conversation, let's look really quick about what's coming down the pipe. On the node side, we're continuing to finish up our in-progress work around permission schemes, multi-signature, and the audit ledger. So we're going to harden view change, fix the audit ledger, and finally move the permission scheme to the config ledger because we have the audit ledger ready. We haven't quite figured out how much of this work we're going to be able to get done in the next sprint, but that's what's coming down the pipe. Once that's done, we can cut a release, and then we go back to finishing all the multi-signature support for trustee actions and doing DID, fully qualified DID work, and then going on to the pluggable request handler. If you look on the Indy Node release train, because we've been finishing up this work that's been in progress for a long time, we think we have a pretty good idea of what the next probably 6 releases are going to be. And so you can look at that and get a sense for where we're going, and we'll keep that up to date on our progress. On the Indy Node, on the Indy SDK side, it's a bit messier because that collaboration process with the community around agent-agent, the agent-agent protocol is, it takes time to do stuff in a way that works for everybody. And there's a lot of these standards, these HIPEs that are still in progress that aren't finalized, so it's hard for us to figure out how long things will take. But it is our top priority. So the next sprint, we're going to do some more of this agent-agent work. There's a lot of architectural questions, so we might pick up some other work related to improving the VCX pipelines and improving VCX testing. We're going to try and do some of that. And then we have some bug fixes and other tasks we'll try and interleave with this effort. But we don't really understand our release plan for the SDK because we don't know how long these HIPEs will work. I should hit release on the service pack. But the next release where we include agent-agent compatibility, where we will have a 2.0 and a 1.9 version of the API, a 1.x and a 2.x version of the API for the compatible way and the current Evernym approach. We don't have a clear timeline on that. We're excited to work with everybody who's attending the Agent Connect-a-thon for the Sovereign Foundation's hosting. We're going to do that next week, and that'll give us a better idea of how close we are. that is our plan. So thank you, team, for putting together an excellent demo, very educational. I expect that's going to be a good resource for people in our ecosystem for some time to come. And we look forward to getting feedback from everybody who's interested in collaborating with us, especially around the HIPE process and Credential Exchange. That's going to be really useful. And the long-term future of the Ledger 2.0 architecture that we've been talking about. So we look forward to working with people on that. So thank you, and we'll post another video in 2 weeks.
Thank you.